Hello and welcome to part 49 of my video series on Blender 2.7. In this video I'm going to be talking about how to simulate rigid body physics in Blender. What does that mean? Well, the example that I'm going to give you is, imagine you took some time and you set up a bunch of children's toy blocks in a tower. And then you wanted to animate that tower falling over and all the blocks tumbling down, hitting each other, colliding with one another, and finally landing on their resting place on the ground. Well, you wouldn't want to animate that, and neither would I. Luckily, Blender has what's called a bullet physics engine built into it now. Let's go ahead and jump in. I'll click on the splash screen to get rid of it. The first thing I'm going to do is I'm going to grab my default cube and drag it straight up on the Z-axis because I want to separate it from the floor, which actually doesn't exist yet. We just have this ground grid. I'm going to go ahead and press Shift-A on my keyboard and add a new mesh plane. So I'll click there, and then I want to scale this up to make a larger ground, because what I wanted to start off by doing is I want to animate this cube falling and tumbling and landing on the ground. So with my ground selected, I'll press S on my keyboard, and then maybe I'll just press 20 on my keyboard and then press Enter. So now I have a ground that's 20 times its original size. And so now what I need to do is I need to make these two objects, the ground and the cube, physics objects. Now how do you do this? Well, over in the left side of your 3D viewport is of course the tool shelf, this small panel over here. If you can't see it on your screen, of course you can press T on your keyboard. T hides it and T shows it. Otherwise you can of course press this little plus to bring it up. And a few versions ago in Blender we got tabs at the side of this tool shelf. If you have an old version of Blender you might not see these. You might just have to scroll all the way down, or better yet, go and get the latest version of Blender. At this recording time, that's Blender 2.74. Now there is a physics tab at the side of this tool shelf, so I'll click on that. Adding a physics to any object is very easy, or at least any mesh is very easy. You just have the object selected. In this case I have my cube selected. I'm going to click Add Active. I'll make this a little bit wider so you can actually see that. When you have a mesh selected and you click on Add Active, it makes it an active rigid body that's affected by gravity in your scene. So I'm going to click on Add Active. And the only thing you see right away is that you see it's outlined in green. That lets you know that it's actually not going to be acting like a normal object. It's part of a physics simulation. Okay, great. I'm going to select the ground now. And the ground has, of course, by default, an orange or yellowish orange outline. I'm going to make this one a passive object. Now, what's the difference here between active and passive? Well, we don't want our ground to start falling as soon as we start simulating this scene with physics. We want the ground to be stationary, and that's what a passive object is. It's still part of the physics simulation. In other words, objects can collide with it, but an active object is one that actually is affected by gravity, like this cube is going to be. So how do you actually run the physics simulation now that we have both objects part of our physics scene? Well, I could press Alt-A on my keyboard, and Alt-A is of course play, but what I'll do is I'll grab this little top crosshatched area, the little triangular area up here, and I'll drag it straight down to divide the window into two, and then I'm going to change this bottom window type into a timeline. So we get, of course, our record buttons and we can see our progress over time. So of course that's the timeline window. What we have here now is our play buttons and go back to the beginning button. So I could press this play button, and that would do the same thing as pressing Alt-A. As you can see there, the keyboard shortcut is Alt-A. So I'll do that, Alt-A, and as you can see, the physics simulation starts. The playhead is moving, that green bar is a playhead, and you can see my frame rate up here. It's 24 frames per second most of the time. And what just happened here is it filled up my current timeline, which is 250 frames, with this kind of orange bar, which actually is a cache. In other words, memory that holds all of the information from this simulation. So it simulated the cube falling and it lands quite realistically on the ground. That's great. We'll watch it again in a sec. There it goes. It lands and it bounces a little bit. That's great. And this orange bar is the cache, and that's very important. We'll talk about that in a few minutes. I'm going to press Escape to go back to the beginning and stop the simulation. Of course, now we have a cache built in, and that's all good and great. Let's go ahead and resimulate this. So an important thing here is that if we change any object in the scene, the cache will no longer be good. We have to resimulate, and if you have a lot of objects in your scene, that might take a little while. So let's go ahead and press R with the cube selected. And I just want it to be sort of at a very odd angle with maybe a corner pointing down. So now when it lands, it won't just land flat on its side, it'll have to tumble, and we'll see an even more interesting physics simulation. So I'll press Alt-A, and that looks pretty good. We got a cube falling, and it lands, it has to kind of tumble to find its spot flat on the ground. We're good to go. You might be thinking to yourself, hey, this looks like a very slow scene. Why is it acting so slow when it falls? I'll go back to the beginning, and you can see that it's taking its time. Well, the reason why that is because by default, Blender thinks of the units in your scene. In other words, the scale in your scene as being very large. This cube is actually, if you think of it in the metric system, it's 2 meters by 2 meters by 2 meters, and the ground is very large. I believe it's 20 meters by 20 meters. So this is a very, very large object falling in a very large scene. Therefore, it's slow, and it is pretty accurate. I need to mention here that Blender physics does not simulate small objects very well. You have to work with large objects, and I'll talk about at the end of this video how to make things simulate faster so that things appear at their correct size depending on what the scale of your scene is. Alright, so we've mastered a cube falling on the ground. That's great. I'm going to press escape. I'm going to get rid of my cube. I want to move on to something a little bit more interesting. I'm going to make a chain. So what I'll do here is I'll actually press 7 to go to my top view. And so right now I'm at top perspective or top persp. So I'll press 5 on my numpad or go down to the view menu and select view top and then view persp ortho. Now I'm going to add a torus. So I'll press shift A. I'll add a mesh torus right there, and I'll zoom in on it, and it's got a lot of these rings going around it. So before I even move it, I'm going to edit the torus. Right now it's got 48 segments. I want less than that, maybe 24. Great, now it's a lot less or a lot lower poly. I'll press tab to go into edit mode. I want to stretch this torus out to make like one link in a chain. So I'm going to hold, actually I'll press A on my keyboard and then hold Alt and right click on one of these edges to select all of the edges around that part of the donut or torus. I'll hold Shift and Alt and select this edge or right click on it. So now I have 2 edge loops selected. I'm going to bevel that edge loop there, or both of them together. So I'll press Control B on my keyboard. Control B is of course bevel, which when you pull your mouse out and then click, you get 2 edges wherever there was one selected. Great. I'll press A to deselect all, and I'm going to turn off, and I believe this is called Limit Selection Divisible. That will make it so that when I select everything on the top of my torus, in other words, I press B on my keyboard, for box select, I can now click and drag and select everything on the top half of the link of my chain, including the bottom half. If I didn't have this button light, it wouldn't have selected that bottom half. I can drag it up or on the y-axis to make a link of a chain. Great. I'll press tab to go back into object mode. Maybe I'll go to my front view. I'll press RX -90 on my keyboard and press enter. So now I've got a link of my chain facing me from the front view. I want to make kind of a bunch of links of chains. Now, I did just mention that Blender's physics works better with large objects, although this is very, very large, so I'm going to scale it down just a little bit. I'll tap S, of course, and make it just a little bit smaller. It's still, by the way, 1 meter long instead of 2 meters long approximately, so we still have a very large scene. Let's go ahead and make more links. So I'll just duplicate this single link here, Shift D, and then I'll press Z on my keyboard to move it straight up. And what I want to do here is rotate it on the Z axis. So I'll type R, Z, 90 or 90 and then press enter. So again, that was R, Z, 90 and enter to make that link turn 90 degrees on the Z axis. I'll select both now and I'll press Shift D and Z and move it straight up so we have more links attached. Great. One handy little keyboard shortcut, and I'll click on my spacebar actually. I'm going to type the word repeat. There is a special keyboard shortcut or function in Blender called repeat last, which is Shift R for you keyboard shortcut junkies like me. If you press Shift R, it'll repeat the last action. In other words, the last thing we did was duplicate and move up and click. So that just redid it again. So Shift R, Shift R, Shift R. Great, we've got a chain. But wait a minute, I forgot to apply physics to this first link, and therefore when we made more copies, it didn't make any of these have physics on it. We could select each one and then go to the physics tab right here, and we could say add active, but that would take too long. So what I'll do is I'm going to make the first link active, so I'll click on add active, and then what I'll do is I'll press A and box select the rest of them and select the original one that has active on it last, so I'll hold Shift and right click on that one, And now I can use, under the Physics tab, Copy from Active. That'll copy the physics properties, and we'll get to some physics properties over here. If you have the last one selected that you actually have physics applied to, you can just say Copy from Active, and now all these other ones turn green. Great, let's go ahead and take a look at what this looks like. So I'll press Alt-A or press play in the timeline, and it didn't do what I thought it was going to do. Actually, I was expecting that. The reason why we got an explosion of these chain links is because by default the collision bounds on a mesh. In other words, where it thinks there is a force field, where it thinks that there is a solid object, is not necessarily using the actual mesh of your object. If I select one of these lengths, I'll select the bottom one, or the first one that I made right there, and I go over in the Properties window to this Physics tab. It looks like a little bouncing ball, and I go down to Rigidbody Collisions. This is actually where the Physics tab over here in the tool shelf is referencing almost everything that's in this little panel. The real settings are over here. And under the Rigidbody Collisions area or section, there is a shape pull down. And by default, any object that you apply physics to uses a shape called a convex hull. And basically what this is it makes a very, very simple sort of virtual mesh which shrink wraps your mesh that you have that you want to simulate physics on. So what does this mean? Well, it means that with convex hull, you can't have intersecting objects or objects with holes in them where other objects go through that object. It doesn't work with convex hull. You think of if you took this chain link and you kind of shrink wrapped it with plastic, there would still be like a flat surface over both of the openings in this chain link, so it wouldn't work. For this chain link and any object that you want to have intersecting with other objects, you have to change the shape type of the collision area to mesh. There is more options here. Convex hull is a very good option for lots of simulations, but mesh, it does take longer, and it might not be what you want. Generally, convex hull is a great option unless you have something like this. Of course, you can change that to sphere if you have a really perfectly round object. There are more options here. I'm not going to go through anything except for these top two. I'll change this to mesh, and then what I'll do is I'll box select with the B key the rest of my chain links, hold shift, select this one last, and copy from active. Alright, let's go ahead and press Alt-A, and as you can see, the chain now works exactly the way I want it to, or pretty well. All the links stayed together, they interacted with one another when they kind of fell down on top of one another, and all was good. I'll press escape on my keyboard. It looks great. What if I don't want this chain to fall? What if I want it to be attached to something else? Let's say it was attached to a ceiling up here. Well, I could take this top link, and with just this top link selected, I could make it a passive object. So what that means now is that it won't be affected by gravity. It'll stay in spot, but it'll still have that mesh shape, so it'll interact well with the other links, and it'll hold the other links up. So I'll press Alt-A, and we'll see what that looks like. Great, the chain is falling, but it's sort of waving in air. It's not going all the way down to the ground. That's exactly what I want. The last thing I want to show you in this video is, my favorite thing to do with physics is to set up a chain of dominoes. So I'll press A and B and box select these chain links and delete them with the X key, of course. I'm going to press Shift C on my keyboard. Shift C will make sure that my 3D cursor is in the middle of my scene. And I'll press Shift A, and I'm going to add a cube. And so to make my dominoes, I want to scale this a little bit. So maybe I'll press G and Z and 1 to move it up first on the ground. That was G, Z, and 1. And I'll use my scale gizmo. I'm going to scale this to be a little bit narrower, and of course it's got a lot thinner. And that looks pretty good to me. And maybe even more like that, to make it more like a domino. It's still really big, so I might scale this down, but that's not really necessary unless I have other things in my scene. So, great, I have a domino. My ground still, of course, has a passive, or is a passive object in our physics scene. So I'll select the domino, and I'll click on Add Active. Now by default, again, the shape for the collision bounds is a convex hull, and that does tend to work better. If you use the mesh, You might not get the results that you want when the domino falls and lands on the ground. It might be all shaky if you use mesh. So we'll just leave this at Convex Hull. You could use box. That would probably be okay too, but I'll just leave it. So if I press Alt-A, it lands. It sort of wobbles back and forth. But we're getting a lot of jiggle, and actually it's falling over. What's happening here? Well, first off, I have this domino quite far from the ground. If I go and press 1 on my keyboard to go to my front orthographic view, you can see that, if you can see this grid, if you're looking at this video in 1080p, that this domino is basically a meter tall, but it's also half a meter off the ground and very narrow. So let's lower it down. What else can we do here? Well, I could also change the collision margin. Now by default, not all objects are going to touch in the physics simulation. They might look like it, but there is actually a little bit of a force field around each object, stopping the objects from really getting close to each other, and that's meant to stop objects from actually intersecting or going through each other. We can change that. If I have the object selected, I can click on this collision margin under the Rigidbody Collisions section, and now I can define the margin. By default, it's 0.04 Blender units. Let's go ahead and see what that looks like. I'll press Alt-A. Great, I think that even improved it. I'm not sure what it does by default. I really think it depends on the size of the object. I'm not sure, but that seems to have solved it. I wouldn't turn this down to 0. That would not look good and you might not get the results that you want. Sometimes I turn this down to 0.02, so half as much, but let's go ahead and see what that looks like. Great, it looks fine. Maybe there's a little bit too much wobble here, so I'll turn it back up to 0.04. Great, let's go ahead and duplicate this. So I'll press 1 on my keyboard. Actually, I'll go to the side view with the 3 key, and I'll duplicate this. So Shift D and then Y on my keyboard to move it over. Great, I've got 2 here. Shift D, Y, Shift D, Y. And then I'll take all of these, I'll box select all of these, and Shift D, Y. Oops, I duplicated the lamp as well. Let's get rid of that. X, great. Let's go ahead and simulate this. So Alt-A, and I've got a stack of dominoes. But wait a sec, the dominoes need to fall over. What can I do to actually make them fall over in a way that I want? Well, I could take this first domino and go to my side view and pre-rotate it. That means I'll have it already at an angle where it's going to tip over. Let's see what that looks like. I'll press Alt-A. And that works. We get a domino scene. They're all acting the way they should. That's great, but what if I want to have an animated object come in and affect the scene? Well, I can do that. What I'll do is I'll press Control Z to unrotate that, and I'm going to add a finger object. A finger is going to come in and actually push this first domino, which will then cause them all to topple. So I'll go to my side view. I'll put my 3D cursor over here, and I'll press Shift A. In fact, I'm going to have a monkey do some monkey business here and topple them all over. So I'll make that a little bit smaller. Maybe I'll add a Subdivision surface modifier to this. Great, we've got a monkey. Maybe I'll make it smooth. And we want to make it do we want to make it an active object or a passive object? Well, in this case, it actually doesn't matter. What matters here is I'm going to be animating this object. Now, when my scene first starts, the dominoes are not on the ground. I want to give them some time to sort of land and settle themselves out before the monkey comes in and pushes the first one over. So what I'll do here is I want to animate this monkey head. So I'll turn on my record button down here in my timeline, and I want to be right there when it starts. So instead of just moving it, I can actually press this little key button, and that will insert. Did it? I'm not sure. I can press I on my keyboard. That's I for insert keyframe, and I can insert a location keyframe. Great, that did it. I didn't have. That's why that key didn't work. I didn't have a type of keyframe that I wanted to use, so just ignore that last part. I've got a keyframe with the I key on the frame 0 of my monkey head right there, and I want to go a little bit later. Let's give these dominoes about 30 frames to sort of land and settle. So on frame 30, I'll press I and insert a location keyframe. So now my monkey head is static or not moving between frames 0 and 30. Let's go to 15 frames later, and I'm going to move the monkey head. I've got the record button turned on, so I'm going to move it to intersect with that first domino. Of course, we're not simulating right now. It will, and this domino will be affected by the monkey head. It will topple over. Great, I've got a keyframe there now. I'm going to make the monkey head move back, so 15 frames later, with the record button turned on, I'll move the monkey head back, and I'll turn the record button off. So now we've got an animation of the monkey head moving in and then moving back. Now if I just play this or simulate this, again I go back to frame 0 and press Alt-A, nothing happened, because we didn't actually activate this monkey head as an active physics object. Now, what I just said was a little bit misleading. You can actually say add active or add passive, but there is one extra checkbox to click. If I click add active and simulate the scene again, so Alt-A, the monkey head will fall and it won't use any of this animation that I just created. So what I have to do is I'll go back to the physics tab with the monkey head selected, and I have to click on animated. Once I do that and I resimulate the scene, I'll go back to frame 0 and I'll press Alt-A. It won't be an active object, but it will be part of the physics simulation, and the dominoes will topple over. It actually doesn't matter once you click this animated button. As far as I've found, if you have passive or active there, both allow for animation. Once you click animation for either option, it doesn't matter what the object is, it will not be simulated in your scene. So this works just as well with passive. Great. So I've got a scene. I like it. I want to incorporate it into my animation. I want to render it out into my movie. How do I do that? Well, it's very important to save this file, because this file should have, or you want it to have, this cache as a part of it. So what I'll do is I'll just do a quick save, file, save, and I'll go to my desktop and I'll save this as dominoes. .blend, great, I'll save as Blender file. What I need to do here is actually bake my physics cache into this file. So with any of the objects selected that have physics on it, I'll go to my physics tab, and I believe, no, we have to go to the scene tab in our properties window. And if you scroll down, you'll find a couple of sections that are relevant to simulating rigid body physics. There is a rigid body world section and a rigid body cache section. The second one is very important. The first thing you'll see in it is a start and an end. So even if your scene has like 100 dominoes and you want to simulate it all, by default what you might find is that the simulation gets cut off at 250 frames, even if your end down here in your timeline is set to a higher number, like 1000. Your physics simulation will not go past 250, and you won't know why. Well, the reason is because by default your cache is set to a limit of 250 right here. So I could set this up higher to 1000, which would of course make the cache larger in file size. That's okay. But what I'll do here is I'm going to bake the current cache to this file. So click on current cache to bake. And what that'll do is it'll lock all of these objects in stone in terms of their simulation. I can press Alt-A, and everything works as expected. I can animate and move and work with other things in my scene, and this cache, the simulation, is solid. It's final in the scene. You won't mess it up. It's fine. Of course, you can free the bake if you want to resimulate. That's all good and great. What if, though, I want to take this cache, this simulation, and bake it to keyframe so I can edit it using, of course, all of the animation techniques that I already know? Well, what I'm going to do is I'm actually going to free this bake. So I'll click on free bake, and I'm going to select all of the objects in my scene. So I'll just do a quick hold shift and right click on all of the objects in my scene that I care about. I don't care about the monkey head because that's just animated, and I don't care about the ground because that's just static. What I can say is over here in the physics tab of my tool shelf, bake to keyframes. And instead of having this funny cache bar down here, once I click on bake to keyframes and then press OK, it's going to take all of that simulation and bake it to keyframes. And so now we have keyframes that of course we can edit. If I were to grab a dope sheet or divide this one into two, and turn it into a dope sheet. If I select any of these dominoes and zoom in, you can see that I have a lot of keyframes that I could delete or work with it any way that I like if I want to modify the simulation. That's great, but this is a lot of frames. So of course you can see I'm going through a lot of things or lots of elements that you need to know to work with a simulation in Blender. There's just working with the basic objects, there's adding animated objects in here, there's turning your simulation into keyframes and making sure that you have a cache that's long enough. What I want to do now is simplify all of these keyframes down with just this object. In fact, what I'll do is I'll click on this little arrow down here. That's part of this dope sheet window. And if you're not sure what a dope sheet is, check out my video on Intro to Animation, in which I talk about how to actually animate objects with both this dope sheet and why you would want to use this dope sheet along with the timeline. So I'll put a link to that on the screen right now. If I want to work with the keyframes of any of these dominoes, I have way too many to work with. I have basically, or not basically, I do have a keyframe for every single frame in my sequence. That's 1,000 in my case, or 250 as I simulated it. No, it's 1,000 in my case keyframes. That's way too many. I don't need that many. This domino, it stands still for the first little while, right? If I go back to that point in time, you can see that it's basically still all the way up until right there. So why the heck are all these keyframes here? Well, unfortunately, when you say bake to keyframes with your simulation, it just takes every frame and makes it into a keyframe. So how do you solve that? Well, there is a great add-on in Blender that actually takes your multitude of keyframes and looks at the important ones and it'll simplify it down. Let's go ahead and add that add-on and I'll show you how to use it. So I'm going to go up to the File menu and click on User Preferences. And under the Add-ons tab, what I want to do here is search for Simplify. So I'll type in Simp, and there it is, Add Curve, Simplify Curves. I actually already have it activated. You can click on a little checkbox and you can say Save User Settings. That's great. Let's take a look at the information about it. The description is simplifies 3D curve objects and animation F curves. If you're not sure what that means, why it uses the word curves, it's because when you're working with 3D animation, all of the movement data you can think of as being on a graph. And graphs, of course, if you've taken math in high school, graphs have curves. So that's why it uses the word curves for keyframes and animation. It doesn't actually have, or this add-on doesn't have any actual button in your interface. You have to search for it. So I'll click on Save User Settings. I'll close my preferences window and I want to simplify the curves on this domino. Yes, you have to do this one domino at a time, but it's still a great tool. So with this domino selected, and I'll click on this little arrow so you can only see the keyframe of that one object, not all the dominoes and the monkey head. What I'll do is I'll press the space bar and I'll type in simp again, and here you can find where that add-on is. Once you click on Simplify F Curves, click, you actually do get a little bit of an interface at the bottom of your tool shelf, and by default it only has one setting and it's set to 0. What this is doing is it's asking you how much you want to simplify down these keyframes by. Well, it's not simplifying it down at all right now, that's why this number is at 0. I'm going to click on the right arrow once, and as you can see, once I do that, it's looked at all the animation data and it said, hey look, this domino falls from frame 1 to frame 7. And then it's pretty much still. There was some jiggle, but it's pretty much still all the way up until it's about to get hit by the other domino, and then it has a bunch of keyframes, and then it's basically toppled over. It's sitting on the ground, and it's pretty much still. It slides a little bit, and of course you can change this number. I think way back in the day I thought that maybe 0.14 might be a better result. Maybe it was 0.014. Yeah, that's a little bit less simplified down. That's kind of what I want more. Great, let's go ahead and repeat that process. I'll select this domino. I'll press the space bar. The space bar knows the last thing I searched for, so I can just click or press enter on my keyboard and then just click in here and press enter. And that'll simplify that one down too. So the process is select the next object, space bar, enter, click, and press enter. Yes, it's a little bit cumbersome, but I think it's worth it to get that number of keyframes down to a more manageable number. You will notice that my dominoes are a little bit too far apart. What I should have done here is I should have gone to the physics tab, and of course this object no longer has physics on it, and I should have changed the margin to a much lower number for this scene. Okay, so that's dominoes. I want to talk about one more thing, and that is how to speed up your physics simulation. What I actually have to do here is I've got a bake scene to keyframe, so I'm going to get rid of all of these objects, and I'm going to add in just a simple cube. So I'll click X to delete all those objects. I'll press Shift C to bring my 3D cursor back to the middle, and I'm going to add a new cube, and I'm going to make it, with the Physics tab, a active object. Great. I'll go back to the beginning, and I'll press Alt-A, and it falls and tumbles to the ground as I want. Now, that cube took a long time to fall because it's, again, a 2 meter by 2 meter by 2 meter cube. How you can solve this sort of large scale problem is, again, under your Scene tab in your Properties window. I believe it's under the Rigid Body World area. Speed. Right now my speed is set to 1. If I want to make the scene seem smaller, or just make this look like maybe like a 1 centimeter by 1 centimeter cube, well, I can turn this up. So if I turn it up to 3, I'll have to re-simulate. So I'll go back to the beginning and then press Alt-A. It happens a lot faster. So you can imagine if this was a very, very tiny cube falling a very, very short distance, that might be more accurate. I think something like 1.5 is a good result if you want to make like a smaller scene. So Alt-A, that acted a little bit faster, and that looked good to me. But that's going to be it for this video. Thanks for watching, and I'll see you next time.